Today we're going to look at section 2.3, which is about linear functions and slope. So today we're going to calculate slope, write an equation of a line in both point slope form as well as y-intercept form. We'll graph a line using the y-intercept form, and then we'll graph horizontal and vertical lines. So slope of a line. Slope compares the vertical change to the horizontal change. So you've probably heard of this as rise over run. So this happens when moving from one fixed point to another along the line. And remember, we always read the graph going from left to right. So here's our definition. The slope of the line through two distinct points, x1, y1, and x2, y2, is this. We're thinking change in y over change in x. So we're thinking of subtracting y2 minus y1 over x2 minus x1. Obviously, we don't want our denominator, which is x2 minus x1, to turn into 0. There's 4 different types of slopes. So we have a line that is a positive slope. That means that the line rises going from the left to the right. Negative slope means that the line is falling going from the left to the right. A 0 slope is going to be a horizontal line because there are no changes. And then a vertical line would be considered an undefined slope. So we're going to find the slope of the line passing through each pair of points, and then we'll indicate if the line rises, falls, is horizontal, or is vertical. So it doesn't matter which ordered pair you make what. I usually just make the first ordered pair the x1, y1, and the second ordered pair the x2, y2, and we're just going to calculate. So once again, we're thinking of the change in y over the change in x, or the rise over the run. So I'm going to subtract the y's, put that over the differences of the x's. Notice that in this case, I had to subtract a negative down here with the x's. Well, negative 2 minus 4 is negative 6. Back-to-back negatives, we're really thinking addition. Negative 4 plus 3 is negative 1. And negative 6 divided by negative 1 gives us, positive 6. So that is my slope. Notice that because it's a positive number, it's a positive slope, and so positive slopes rise. So this line is going to have it rising. In the second problem, I am going to, once again, put the first ordered pair as x1, y1, the second ordered pair as x2, y2, and we'll calculate. So I want to subtract the y's. So we'll have y2 minus y1 over, and now I want to subtract the x's. So x2 minus x1. Well, 5 minus 5 is 0. Negative 1 minus 4 is negative 5. 0 divided by any number is going to be 0. And so because we're dealing with a 0, we're dealing with a 0 slope, and a 0 slope is horizontal. All right, so let's talk about point slope form of the equation of a line. So point slope form of a non-vertical line with slope m that passes through the point x1, y1 is the following. It's y minus y1 equals m times the quantity x minus x1. So we're going to write the point slope form of the equation of the line passing through the points negative 2, negative 1, and negative 1, negative 6. Then we'll solve for y. So once again, we want this formula right here. Y minus y1 equals m times the quantity x minus x1. So they've given us 2 points. We're going to use that information to do what we just did in the other examples. We have to find the slope because that's our m. So to calculate m, I'm just going to make this first point the x1, y1, and the second point x2, y2. So we'll have negative 6 minus negative 1. That's my y values being subtracted. That's over negative 1 minus negative 2. Those are my x values getting subtracted. So we've got several back-to-back negatives. Well, negative 6 plus 1 is negative 5. We've got negative 1 plus 2, which is positive 1. So we can just even simplify it down to just negative 5. So I know that that's going to go into my equation for m. It honestly doesn't really matter which one of those points you plug in for the x1, y1. But since I already labeled that first ordered pair of negative 2, negative 1 as the x1, y1, I'm just going to do that. Okay, the x term and the y term that don't have that little subscript number, they stay x and y. So I'm going to start plugging in numbers. So that means that we are going to have the number -5, -2, and -1 to plug into our three variables right there. Okay, so we're going to have y minus, my y1 is -1. That equals my slope, which is -5, times the quantity of x minus, and then x1 is -2. So we can simplify this because we've got back-to-back negatives. So our answer would be y plus 1 equals -5 times the quantity x plus 2. Here is my slope-intercept form, or sorry, point-slope form. And now they said to solve for y. So now I'm going to take this equation, y plus 1 equals -5 times the quantity x plus 2. I'm going to get rid of the parentheses by distributing that -5. So we'll have -5x minus 10 on the right. And then the last step to get the y by itself, I'm going to subtract the 1. So then we have y equals -5x minus 11. Okay, had we used that other point of -1, -6, that's perfectly fine. Then we would have had y plus 6 equals -5 times the quantity of x plus 1. Solving then for y, we would have gotten the same equation. We would have gotten y equals -5x minus 11. So that's why it doesn't really matter which one of those 2 points you plug in for the x1, y1. So there are always going to be 2 possible point slope forms if you're given 2 points. But there can only be one equation for the y equals. Okay, so go ahead, pause the video, write the equation in point slope form, and then solve for y. Okay, so I did write both combinations as far as how you could have set up your point slope form, but regardless of which one of those you used, your final equation for y equals should have been the same. But notice that we had to solve for our slope first. Our slope was 4/3, and then we go ahead and plug in our numbers to get the rest. Okay, so solving for y, well, that's because we were really creating slope-intercept form. So slope-intercept form of equation of a non-vertical line with a slope of m, a y-intercept b, is y equals mx plus b. So how are we going to graph a line if it's in the slope-intercept form? Well, we identify the slope in the y-intercept. We plot the y-intercept so we have a starting point. And then we use the slope to move up and down, followed by left and right. This gives us a new point, and then we can continue that process again by moving either up or down and then left or right from the new point to continue getting more points for the line. Obviously, it should be a straight line. We want arrows on either side of the line as well. All right, so we're going to graph this linear function. So it says f of x equals. So anytime it says f of x, remember that's just function notation. It is the same thing as if I said y equals. So f of x equals -3/5 x plus 1. So since it already has it in our slope-intercept form, we can identify those pieces. Slope is the number in front of x, so that happens to be this -3/5. Our y-intercept is going to be the number that is not attached to x, so it looks like +1. So as an ordered pair, that's 0, 1. Don't forget that that negative goes with either the 3 or it can go with the 5, but you only want it with one of the numbers when you're thinking about the movement. And remember, because it's a negative slope, our final picture should have us falling. We should go from high on the left to low on the right. So I'm going to plot my point at 1 on the y-axis. If I follow the first number where I have -3 over +5, well, -3 means I move down 3, 1, 2, 3, and then 5 to the right, 1, 2, 3, 4, 5. Plot my point. And I could do it again. I could go down 3, and then 5 to the right, plot my point. Or from the y-intercept, I could have used the other slope. I could have done +3 over -5. So I could have gone up 3, but then 5 to the left, or up 3 more, 5 to the left. Notice that all of those points, when I then take a straight edge and connect them, putting arrows at the end, gives us a nice straight line. And notice that our line is falling, which makes sense because we have a negative slope. All right, so when we're talking about horizontal and vertical lines, a horizontal line is given by the equation y equals b. B just means some kind of number. B is also the y-intercept. Okay, so notice that when you're looking at a horizontal line, your x value could be any number that you want, but your y value is always the same. That's why it's y equals and you have a specific number. It will always be that number for y. If we're looking at a vertical line, it's of the equation x equals a, where a is a number, a is also the x-intercept. So that means x will only ever be that number, but y could be any number, which is why then we're moving up and down, going vertical. X has to be the number, but y could be anything else. So we're going to graph each equation on the same graph. So if I have x equals -4, that means I go over to -4 on the x. There's my x-intercept. And then I want x to always be -4, but my y to be any number that I want, which is why I have then a vertical line. If I want then my second equation, y equals 7, well, 7 is then the y-intercept, so it's on the y-axis. X can be anything it wants, but y is always going to be 7, which is why we then have a horizontal line. I'm not asking you to tell me where these two intersect. I just have two different lines on the same graph. All right, let's talk about general form of an equation of a line. So every line has an equation that could be written in general form. It's ax plus by plus c equals 0. Okay, so equals 0. Remember, we've been talking about that back in previous chapters. When we were talking about quadratics, we were talking about general form. Everything was to one side, it equaled 0. A, B, and C are real numbers. A and B are not both 0. One of them could be, but not both of them. Okay, otherwise, you would then have C equals 0. And unless C really does equal 0, you'd have false statements there. So you need to have at least a term with an X or a Y available. So this problem here says rewrite the equation in slope-intercept form, identify slope and y-intercept, and then graph the line. So right now it's in general form because everything's to one side. To get it into slope-intercept form, which is y equals mx plus b, we want the y by itself. I think the fastest way to get y by itself when something's in general form, move the y. So I'm going to subtract the 6y over. That will give us 4x plus 12 to equal -6, or -6y. And then I'll divide every single term by -6. I'll write the y first, but y equals 4 over -6 is going to simplify down. It simplifies down to -2/3. 12 divided by -6 is -2. So there is my slope-intercept form. Hopefully then we're okay with identifying slope is -2 over 3, or you could think of it as 2 over -3, okay? So we're dealing with a negative slope, so when you know that our line's going to fall, our y-intercept is at -2, so 0, -2. So I'm going to plot my point at 0, -2. I'm going to go down 2, then 3 to the right, down 2, 3 to the right. I can do that as many times as I want. Or I could do the opposite. From the y-intercept, I could go up 2, but then I'd have to go 3 to the left. Up 2, 3 to the left. Okay, notice that. I've got enough points where I can very nicely, with a straight edge, connect those points. I've got an arrow on either side. My line is falling because my slope is negative. There's my answer. Okay, so pause the video, rewrite this general form into slope-intercept form, and then identify slope, y-intercept, and graph the line. Okay, hopefully we got the equation y equals 3/5 x plus 3. So my slope is a positive 3/5. My y-intercept is at 0, 3. Positive slope means I have a rising line. That's us calculating slope, writing equations in both point slope form as well as y-intercept form, graphing, as well as looking at horizontal and vertical lines.